Determine whether the inequality statement is true or false. We'll start down here. 3 times 1/3 is 1. 3 times 9 is 27. Well, 1 plus 27 is 28. And 28 is greater than 5, so this is true. Complete the remaining 4 in your composition book to finish up the warm-up. Break apart the pieces of spaghetti to form the specific lengths shown. In my class, we'll likely use straws and cut them to the lengths provided, but if you're at home and have access to spaghetti, feel free to use that. Then manipulate the pieces of spaghetti and determine whether a triangle can be formed with those side lengths. Record your observations in the table. Keep in mind that my segments are not going to be exactly 3 inches, 4 inches, and 5 inches, just because I'm on a screen, and so depending on your computer, it may be larger or smaller, but they will be set up to be the same types of values here. So here I have the 3, 4, and 5 piece. Our job is to connect the endpoints and make sure that all 3 endpoints touch. So this does not create a triangle because there's this big empty gap. I can rotate, but this does not create a triangle because this endpoint and this endpoint are not touching. So we're going to continue to rotate these pieces around until all of them are connected. Like so. So can a triangle be formed? Yes. Now let's do 1, 1, and 5. If I place this one over here and this one over here, this endpoint needs to end up over here. But if I keep these endpoints touching here and here like they're supposed to be, no matter how I rotate these two little one segment pieces, they're never going to reach each other. And if I move it over here, this endpoint doesn't match up where it needs to. So no, I cannot create a triangle with these 3 side lengths. Here I have the 7, 14, and 5. I'm going to match up these endpoints here. Then I can rotate this one. And I can rotate this one. But again, no matter how much I rotate these, this point is not going to be able to reach this point. Here I have the 6, 9, and 7. I need to rotate so that this endpoint and this endpoint start to go towards each other. And this one is able to form a triangle. Your goal now is to find 2 sets of lengths, so you'll need 3 lengths because a triangle has 3 sides, that can form a triangle. So once you find one group of 3 that form a triangle, you'll need to find a different group of 3 that will form another triangle. And then you will also need to find 2 sets that cannot form a triangle. So you have 3 side lengths listed here and 3 side lengths listed here for ones that do not form triangles. Go ahead and use your spaghetti and measure the different pieces. Then test it out. If you tried one out and it didn't make a triangle, you can place it down here. If you try one out and it does make a triangle, you can list the side lengths in problem 5 or 6. I'll list some of my findings in just a minute. Here were the side lengths that I found to form a triangle and not form a triangle. Do you think there's a way that we could easily check whether the side lengths would form a triangle without having to use noodles or straws? Well, we know if we have a really long side and the 2 pieces coming off of it are too short, it won't make a triangle. So if this is 7 and this is 5 and 2, when we rotate these, the 5 and the 2 are going to just barely touch in that spot to create a side length of 7. But it's going to make a straight line instead of a triangle. And if we have a side length of 8 and a piece that's 2 and a piece that's 3, that only makes 6, and we'll have a gap in the middle where they don't reach each other. So I would also add to your composition book a note that says the sum of the 2 smaller sides must be greater or bigger than the longest side. So here, if we add the 2 small sides together, 4 plus 6 makes 10, and 10 is bigger than 9. This one, our 2 small sides are 10 and 12. 10 plus 12 is 22, which is bigger than 18. But down here, 5 plus 2 is 7, and that is not bigger than 7. And in this bottom one, 2 plus 3 is 5, and 5 is not bigger than 8. So I would add this little note to your composition book or wherever you keep your notes for math class. The diagram shows the location of your school, your home, and Maya's home. What is the shortest path you can take to walk home from school? Well, that shortest path you can take is a straight line from home to school. Maya missed school today. You walk her home to drop off homework. You walk to her home to drop off homework. What is the shortest path you can take from school to Maya's home and then to your home? Draw this path in the diagram and explain why you think it is the shortest. So you're going to walk to her home and then from her home to your home. Go directly to her house and then go directly home. From school, is the path home shorter or longer if you stop at Maya's home? Explain. So if we start at the school and we go to Maya's house, and then we go from Maya's house to home, is that shorter or longer than going from school straight home? The path home is longer if I have to stop at Maya's because it leaves the direct home. We have to veer off the path in order to go to Maya's house. Imagine that Maya's home is on the path you drew from school to your home. How does the distance... Oh, we missed a piece. Could we make the path from school to Maya's home and then home shorter than the path straight home? Well, no, even if we went from school to home, if Maya's house was on the path, it would still be that same distance home. But we wouldn't be able to make it shorter by making a stop at Maya's house. So the answer to the second question would be no. E. Imagine that Maya's home is on the path you drew from school to home. How does the distance of the path from school to home compare to the distance of the path from school to Maya's home and then to your home? Let's draw that sketch out again. If we took the route from school to home and Maya's house was on that path, then the path to Maya's house and then from Maya's house to home would be the same distance. Here I have two fixed lengths, 10 and 4. We're thinking about possible values for x. Remember that the 10 and the 4, if they're the shortest side, need to add up to more than the longest side. But if one of these is the longest side, then this x and the 4 need to add up to more than 10. So let's show some possible values for x. So 10 plus 4 is 14, which is greater than 13.96 or 99. But as soon as we get to 14 here, it makes a straight line, not a triangle. Then if we made the 10 the biggest, 7.71 plus 4 is greater than 10. That would be 11.71. 6.1 plus 4 would be 10.1. That's greater than the longest side. But as soon as we make it 6 and 4, it just makes a straight line, not a triangle. So we can use inequalities to help us figure out possible values for x. This would be the case where the two given sides are the short ones. The sum of the short sides has to be greater than the longest side. So if we solved this inequality, 10 plus 4 is 14. So 14 has to be bigger than x, or you can rewrite it to look the opposite way. Then this is the case where 4 would be the longest, but it doesn't make sense for a side length to be a negative value. So it wouldn't make sense for 4 to be the longest because 10 is longer than 4. And this is the case where 10 is the longest. The sum of the two shortest is bigger than 10. We would solve this like an equation. We subtract 4 from both sides. 4 minus 4 is 0. X still remains here. 10 minus 4 is 6. And we didn't multiply or divide by a negative, so our symbol faces the same way. For problems 10 and 11, justify whether a triangle can be formed with the 3 given side lengths. If not, change one side length so that a triangle can be formed. We are going to add the two shortest sides and see if they are bigger than the longest side. Is 25 plus 80 greater than 90? Well, that would be 105, and 105 is greater than 90, so yes, a triangle can be formed. Here, the two shortest sides are 4.5 and 2.5, and the longest side is 8. Is 4.5 plus 2.5 greater than 8? Well, 4 plus 2 is 6, and a half plus a half makes a whole, so this is 7, and that says 7 is greater than 8. But 7 is not greater than 8. So no, a triangle cannot be formed. We need to change one of the side lengths so that it will make a triangle. So we need to change one of these so that they add up to more than 8. We could have 4.5 and 4, that would make 8.5, and that is bigger than 8. So we could change those to be 4.5 inches, 4 inches, and 8 inches. 4.5 plus 4 makes 8.5, which is bigger than 8. Two sides of triangle ABC have lengths of 5 centimeters and 9 centimeters. What are the possible lengths of the third side? Well, we know for sure that 5 is one of the shorter sides because 9 is longer than it. So we have two possible options. 5 and the unknown side are the smallest, or 5 and 9 are the smallest. Either way, the sum of the two small sides has to be greater than the longest side. In this case, the longest side would be 9, and in this case, the longest side would have to be that unknown side length. Now we're going to solve them as if they were equations. So we'll subtract 5 from both sides here. 5 minus 5 is 0. 9 minus 5 is 4. The symbol is preserved because we haven't multiplied or divided by a negative. Over here, 5 plus 9 is 14. And again, we haven't multiplied or divided by a negative. So x can be bigger than 4 or smaller than 14? What are the possible whole numbers or whole number lengths of the third side? So something that's bigger than 4 and smaller than 5, 6, 7, 8, 9, 10, 11, 12, and 13. These are all whole numbers that are bigger than 4 and smaller than 14. And that's it for lesson 3. Check back for lesson 4 coming soon.